and how can we make them better and more sustainable.
Okay, and you came for the subject, or you came because somebody else said we have to go and I'm taking you there? And she said, I'm taking you there. You're here for the first time as well? Yes. And why are you here tonight?
Yeah, I want to. I want to reduce our carbon footprint, and I also want to challenge our advisors on installations towards a more sustainable solution. Okay. And I feel like I don't have a lot of knowledge about the subject, so I found it really interesting. That.
Yeah. And what's your background?
Architect.
Okay. You're all colleagues. Okay, welcome. Well, I'm hoping. I hope we can satisfy you at the end of tonight. We will have 4 different perspectives tonight. Actually, 5. 4 speakers that have all, in one way or another, contributed to the exhibition that we are tonight in the middle of. That opened last week. Willem van Genugten, Carla Rongen, Jacco Paauw, and Bas Hasselaar. They will each take the stage for about 15 minutes, share their vision on climate positive built environment and the role installations have to play in that, or the absence of installations in that. And then we open up the room to all of you for a discussion and debate. But first, the opening of tonight by KeileCollectief, Studio Adams. She's one of the founding mothers, curators of this exhibition. Please welcome Monica Adams.
Thank you, thank you. Yeah, very happy to be here to tell you a little bit about the exhibition, but also how we got here. It's an exhibition that was made by a lot of officers in the Keilepand, so because of that it was already a very special experience for us, let's say it like that. And it's called How Do We Want to Build in M4H 2030. And why did we want to have this exhibition? Well, as you all know, we are at a tipping point, basically. If we want to change what the mess we are in, we have to do it now. And we wanted to do that in such a way that we said, okay, to learn, we have to first look back 100 years, and then we hopefully be able to find or to make a solution for the future. For those who are online, see some images of the exhibition, where what we did is basically, again, with this 5 companies in the Keilepand, we looked along this whole line of 1900 to 2100 to 4 themes: landscape, urban design, architecture and materials. And that we put in the context of, it's a long section at the end, of M4H, because this is basically what we try to do. I will tell a little bit about this in a minute, that we always try to connect all the big items we have, all the challenges we have at the moment to M4H, because we know that in this area, very quickly, building will start, and all the speakers, I think, have been involved in also looking at some solutions that could hopefully maybe be a prototype here. Very quickly, some of you have already heard the stories, but again, always new people, so very, very quickly. This is the Keilepand. We are in this area, M4H, and it's an area as big as the city center of Rotterdam. And in the coming 20-30 years, this area will be completely transformed to a living and working area. We came here around 8 years ago, and then at that moment it was clear there would be transformation, but not what the ideas of the municipality were. And we started together with the IABR, so the International Architecture Biennale Rotterdam, who also are in the Keilepand as an office, to talk about this. So to talk about, okay, if we know that this new area is coming, what does it mean for energy, for water, for climate? And very quickly we came to the conclusion that to be circular, you have to do that together. So we were very happy that this series was pretty successful. We did, I think, around 15 of these evenings in the turn of a couple of years. But even more happy we were that after a year, in 2019, we understood from the municipality that they wanted to have M4H stamped as a circular development. And they pronounced 8 principles, for sustainable principles for the area. And the whole overall motto is collectivity as a basis for circularity. And that is something what we try to do. So we really try to be more and more trying to find each other to talk about it. Because if you want to be circular, if you want to get the goals of 2050 of the Paris, you have to do that together. And because of that, we have this kind of exhibitions, carbon stories. We started almost 1.5 years ago, and we have all kinds of workshops to talk about it. And then why this exhibition now? Again, building probably will start really quick now. I think 2000 or coming year. And exactly in 2030 this should be done. This is a meerwerpieren in M4H. And of course this really needs to be Paris proof. This needs to be carbon positive, we hope. And this is what we talk about. And this is what we do also with the whole exhibition, because it's a setting to talk about how we get there. So tonight is one of these evenings. 15 September we stop. And be invited, because I hope that at that moment we can also tell you what we have achieved with all the debates and talks about the subject. Thank you.
Thanks, Monica. And first speaker I'm going to introduce tonight is one of the founding fathers. He objected that term. He is one of the initiators. We're doing this with a family, with a team. One of the founding fathers of CARBONLAB, Group A's CARBONLAB, and one of the founding fathers of Carbon Stories as well. He will talk about what it means to aim for Paris proof in 2030, 2050, and what role installations do have to play in that. Please welcome Willem van Genugten.
Thank you. And welcome to everyone. Great that you are here. Zooming in on M4H, let's zoom out a bit. What are we talking about? What is the scale of the problem of what Monica called the mess we're in? The scale is this. Every 28 days we build the entire city of New York. Not just Manhattan, the entire city, all the 5 boroughs. Steel, glass, concrete, light posts, asphalt. This we add to the build volume of the planet every 28 days, so in total 13 times a year. We are now more or less in the middle of that. You can imagine what this means for the Paris Accord. You can also imagine what this means maybe for water quality, air quality. So we need to change this. Another way of painting the picture, when you look at carbon emissions related to construction, related to our sector, worldwide we're responsible for about 40%. Of energy-related emissions. 28% of those are related to maintaining the built stock, the existing building stock, in terms of energy, keeping them comfortable, and in maintaining them by renewing facades, making some changes to those buildings. The other 12% is what we call embodied carbon, all the emissions related to the act of constructing buildings, how to source materials, manufacture building elements, put them on site, and put them into a building. This brings the question, what does this in general mean? How could we decarbonize? And the topic of tonight is, what role do installations play in this? I'm going to tell you an anecdote of a good friend of mine, Jacco Paauw. He's an architect as well, of HOH Architects. He once held a lecture in a chapel, a centuries-old building, designed to speak with people, to address people, great acoustics, good light conditions, good temperature conditions. So perfect, no technology needed. Excuse me. Then, before the lecture started, the technical department of the chapel, of the lecture hall by then, they closed all the windows to make it dark. Then they put on the show lights to make it light. Then the people came in and they closed the doors. It got hot. They turned on the air conditioner, which had a zooming sound. And then they gave microphones to allow the speaker to speak. So conditions that were in themselves perfect, then a lot of technology to simulate an already existing situation. So that brought us the question that we tried to answer with a prototype design. Can we go back to a situation where we look at the design first, don't take technology as a starting point, and then see where technology has to be implemented? So not technology to have as a basis, but only there where you cannot avoid it. We do this because installations over the past decades have become a huge part of the budget, both the financial budget of buildings and the carbon budget. And this increase is not coincidental. It's because we started changing the way we build. We started changing the way we regulate. This coincides with a sudden change in how we construct buildings. So this is about how to integrate the design question. We changed the way we materialize our buildings. This led to a different need for installations to create the right comfort. This coincides, of course, with an incredible rise in carbon emissions, all more or less post-war. This is what it effectively means for the building sector in our country. The remaining carbon budget of the Dutch construction sector, which concerns us all, if we don't change the way we build, is finished in approximately 2028. For the city of Rotterdam, it's actually 1.5 years earlier. You can imagine then we may have to just stop the act of building, or can we spread those emissions over a longer period of time? What you see in the cloud is the impact of the buildings on average of complex urban high-density buildings that we as an office also work on. We know that we are ourselves more or less up there, and we're trying to go down to a baseline defined by the Dutch Green Building Council together with NIBE. Can we lower the carbon emissions per square meter of built area to something that brings us within the limits the planet allows us to operate in? So we posed the question in line with this exhibition: can we design a building that is high density, that fits the needs of tomorrow, of today, that fits within the Paris proof line, and not the Paris proof line of today, because we know our construction usually takes time. What we start designing today should meet the requirements of 5-6 years from now. So we looked at, can we bring a building within the Paris proof lines limitations of 2030? Effectively meaning, can we go from 435 kilograms of CO2 emission per square meter, bear with me, to 139. And we even asked ourselves the question, can you go to 2050 targets, which is 50 kilograms per square meter, which is practically zero. And of course, what is the role of installations in this design exercise? Can we limit the installations? If there's anything you can hardly decarbonize, it's installations, because of the materials they're made of. We made a block of several reasons, but mostly it's a compact block that fits within the urban master plan that we had to keep with, and which gives a material extensive way of building. So you share a lot of materials with as many inhabitants as possible. You share walls, you share facade, you share roofs. So per inhabitant, a limited amount of material volume is required. We made it into a block that is highly flexible, so it's what we call a solid, a building that could basically be anything. So you can extend the lifetime of the building, all the effort you put into it, all the CO2 you emit by building it, over a longer period of time, as long as possible. It can be offices, it can be maker spaces, which in this master plan is required. It can also be residential, so over time it changes function, but it could also be a hotel, it could be a care building, it could be perhaps a car park. And we thought there's probably not one route towards this question, towards the answer. Can we do Paris proof 2030, 2050? It would be a bit weird to only elaborate one solution. So we elaborated two, and we are considering to elaborate another view, but at the exhibition you will find it here. There's two ways of reworking or elaborating the building. One is called build to last. Here the assumption is, what if you can build it and the entirety of the building has a lifespan of 300 years plus? That means you could go heavy, you can work with thermal mass, you can work with materials that have a good thermal control of the inner comfort. And we put ourselves the limitation that it has to be more or less sourced from within 100 to 250 kilometers radius. And then what materials do you get? What can you build from? This is a building which is mostly concentrated on what we call fast fibers. Imagine that society at some point starts to really wonder about where does the wood come from. We get this question every day, where does all the wood come from if we transition to bio-based building? You can imagine the sentiments in society change towards not cutting down trees anymore. So this building consists of as little wood as possible. All the stones we use are lime chalk. I'm not sure if that's translated correctly. Leemsteen. The cores are made of leemsteen. The floors are rammed earth, broodjesvloeren. So the only wood is the actual beams. And the facades are chalk hemp. Inside, outside, all one material. No need for all kind of technical layers, all kind of synthetic stuff, just the material. Then this is what it looks like in section. And the assumption is that for the installation part, now we get to the installations, you only need on the inside of the wall, of the outer walls, you need capillaire matten, with which you can arrange the cooling and the heating. Most other comfort levels are arranged by the architecture, not by technology. That means the whole floor plan is extremely flexible because the floor plate doesn't contain technology. This is an image of what it could look like. There's all kind of other considerations that we put into it, which I will not go into now. Another way of looking at it is the materials are sourced all over Europe. It's a building we call Footloose, a design elaboration for a building that not as a building lasts for 300 years, but maybe as a building system, it lasts for 150 years plus. To put it maybe a bit bluntly, suppose you build it now in M4H floods after some time, then at least you have constructed something that can relocate somewhere else, maybe to Arnhem. So it's a lot of wood, bio-based facade packages, demountable, a flat pack system, so it's like an IKEA, the building can be mounted and demounted quite fast. More or less the same section as you see, so there's no need to change the architecture dramatically in these two cases. And here we chose for a system where the comfort level is arranged that only the space that you actually use, or even the area within a space you actually use, you heat with infrared panels. Both these elaborations have wooden piling, as does the building we're sitting in today. It has wood piling. There's an interesting question why the whole country is on concrete piling nowadays, because you don't need it. Then the question, can we meet the Paris-proof numbers for 2030 with the knowledge of today, with the data of today? Yes, you can. This elaboration is a staggering 8 kilos less than 139 kilograms per meter. Can you even go below the 2050 target? In 2050, we have allowed ourselves the liberty of assuming that by 2050 the energy mix of the Netherlands is 100% renewable. In that case, in the calculation model, all the CO2 material, or the embodied material CO2 scores go down dramatically. That means, of course, we have to do that as a country, as a nation. And it also means that you still need to consider material use. It doesn't mean that we can just go back to business as usual, because energy will be limited. There is a material scarcity, but it can be done. We like to be hopeful. So yes, we can.
If I may ask one or two questions. What was the moment that we became addicted to installations, using it in the way we do now?
As far as I understood, I'm not a specialist, I think you should ask some other people. Around the 1950s, maybe even a bit later, the 70s, when we started to really rely on technology, when we started to design, I'm talking from the designer perspective, regardless of inner comfort, this you fix with technology.
Yeah, I really like the example of the friend you gave in the lecture in the chapel. How many? Give us an educated guess. How many of the installations could we do without? Give us a percentage of everything that has been built in the Netherlands, has been built in Rotterdam, or has been built by Group A, for that matter.
Oh, I wouldn't dare to give you a precise number, but I think we could go at least 50% down. It depends on what type of building. A relatively compact residential building, you can reduce much more than a very complex office block, for example. There's different comfort levels needed, there's different legislation. There you will need more air handling. In a residential building, in this building, if you want to have ventilation, in most cases you just open the window.
Yeah. Give
Opinions on this differ, but we probably
exactly.
get to that
We
today.
will talk about that tonight as well,
Yeah.
about what the user of the building will require. Give me one or two examples of the complaints you will receive from the people who are holding office or living in this building you're about to develop.
One architectural one and one in terms of comfort. We, and I'm sure we'll touch upon this later, we assumed that the temperature differences within the housing or within the block, no matter what function it has, should be bigger. The range of what is comfortable should be stretched. And I would love one of the other guests to go into this more.
Which basically means on a cold February morning you should wear a sweater to work.
For example, yeah.
Okay.
Good shoes, good pants.
Yeah. See you back in a minute. Willem van Genugten. Next speaker will touch upon the question how to create buildings that are both healthy and Paris-proof and do so in a low-tech manner. In the next 15 minutes we will hear the perspective of a building biologist. Please welcome Carla Rongen.
Well, thanks for having me. I'm a building biologist and I would like to say something about how we can create healthy buildings, but also the topic of low tech. And most of the times when I'm doing projects, I do that with my colleague. His name is Frank Schipper, but he's with holiday at this moment. So I will try to do it alone. But we do a lot of projects together because the topics are very narrow to each other. I will explain to you. Well, in the Western world, 60% of the people are sick or chronically sick. And I couldn't believe this number when I was studying building biology, but it's true. And it has to do something, of course, with healthy living, with healthy food and with exercising a lot, but it also has to do something with our buildings. And maybe you can, the name of sick building syndrome, maybe it's very known to you. And how come that buildings are not healthy? That's a question which is really asked me a lot. One of the reasons is the next one. We build a lot. Do I have a pointer? No. Oh, really? I'm sorry. I was looking for the pointer. Is there a pointer on this? No? Well, we built from quite a long time. We are building with mineral-based and with bio-based materials. And we did that until about 1900, and certainly after the war, when we had to build a lot of buildings in a really short time, you can see the change in using materials. when we, for 1,000 years, used materials which are mineral-based, bio-based, out of nature, we had a completely change of materials we were using. And that's the red point you see in the graphic. And those materials are highly synthetic and highly processed materials. So think about concrete, and think about glass wool, and think about pur. I don't know how to call it in English. They are highly synthetic, but there are also a lot of toxic materials in it. And most people don't know that. I give you some examples. What is toxic? Well, think about VOCs. It are volatile organic compounds. And you see the materials in which the VOCs are used in. But I also can show you the SVOCs, and there are maybe 10 other slides I can show you, but I don't have the time for that now. There are about 128 million different kinds of toxic products, products. 128 million, think about it. And most of the toxic materials are not tested what the effect on people is, or what the effect is for our planet. But we use it. We use it in all kinds of materials. You can see it in the table on the left side. There's also another slide about formaldehyde. I guess you know it. And it's very used in a lot of products. And the strange thing, this is one example, and it's well, geldig for the most of toxic products. When you see on the circle on the left one, since 1945, we knew since that time that health risks are connected to using formaldehyde or to breathing it in. Formaldehyde is a gas you can breathe in. So since 1945, in 1980 we knew that it was probably carcinogenic. And in 2004 we knew it for sure. It is carcinogenic. And I was wondering, why are we still using it? And I think I know the answer. Maybe we can discuss this later. But we are still allowed to use it. And I think that's very strange. These are the numbers. This one. These are the numbers which you can breathe in at max without the risk of becoming sick. It are from the guidelines, from the building biology, or from the AGEV, and the World Health Organization says 100 microgram per cube at max you can breathe in without the risk of getting sick. But these are the numbers we allow. So when people work with it in the factory, for instance, making CLT or making glue or something, this is what's allowed to breathe in. And I think, again, it's very strange because formaldehyde is carcinogenic. And what I advise when I'm in a project and I'm advising a lot of companies how to build on a building biology way, it's most of the times it's with natural materials. And for most of the construction materials we need in the buildings, for most of them there is already a bio-based or a natural alternative you can buy already. So why use other materials? These are some examples. This is CLT without glue. This is chalk hemp bricks. This is prefab straw. And this is the rammed earth. And I think you can also make a very pretty building with bio-based and natural materials. To be honest, I can tell about 1 hour if you want, but I don't have the time. But when you are building a healthy building, these results you can get. Let's have a look at the mental function left up. When you have a healthy building, you can concentrate 10 till 25% more. Students achieve better results on their tests. And workers, this is very interesting for in offices. When you have an office, the workers are, have more productivity. And it's really, I think, when you have an office and when you have some employments there to work, you have a responsibility to have a healthy environment. But you can also make a business case of it. And I can tell you later more about that. And there are really companies now making a business case of the higher productivity. It's because of the, now I guess we can check this out later for maybe some questions. Well, I make the step to low-tech because the natural building materials and the bio-based building materials, they have the eigenschap, can somebody help me? Characteristic, thank you. They have very specific characteristics, which means that bio-based buildings fit one-to-one to what a man needs to stay healthy. And it's very interesting that bio-based buildings just give us what we need to stay healthy. Think about humidity, think about acoustics, and think about thermal comfort. And they do it by themselves. And when you use these characteristics, you can make the step to low-tech. I will explain to you. I was very inspired by the middle building. The middle building is called 2226, and it's because in the winter it never gets colder than 22 degrees. In winter it never gets colder than 22 degrees. In summer it never gets warmer than 26 degrees. That's the reason why the name of this building, the middle building, is 2226. And it's interesting that this building doesn't have any installations. And that was very inspiring to us, because it's not bio-based, you can see that, but this has been the inspiration for us from, hey, we want to make such buildings with bio-based materials. And you can see on the graphic what the temperature has done in 1 year. The blue line is the temperature outside. The green line, that's the temperature inside. And you see it is perfectly between 22 and 26 degrees without installations. Well, our roadmap to low-tech consists 5 topics. Build with, how to come there. Build with bio-based materials, build vapor open, use the characteristic of effusivity, use the principles of passive house, and use the characteristic of thermal lag. I will explain. This is vapor open, and it means, to go short, that the construction can give us an indoor climate which is always between 40 and 60% humidity, which is perfectly well for people to stay healthy. So we use that. We use also the program of WUFI. WUFI, we use Ubacus, but we also use WUFI. And with these programs, we can onderbouwen. We can prove, yes. With these programs, we can prove how this building is working. And on the left side, you see a view of Ubacus, and on the right side, you see a view of the WUFI. And you see that the building is in first sight, its first year. The building is really, it contains too much water. And is that a problem? No, it's no problem, because you see in the years afterwards that the building gets drier. So there's no problem of getting mold or getting rot or something. So we know we can use the construction which you see on the left side. And in this case, we checked a cement fiberboard of 9 millimeters, and it's a little bit pity. We use sometimes the cement fiberboard because of fire. And you want to have your building safe for fire, and sometimes we need the cement fiberboard. We checked it. We checked it on vapor open. And the Ubacus said, well, the construction gets 1 minute. That's a bit short, I think. 2, maybe? Thank you. You see the construction gets wet in Ubacus, but we checked it in the WUFI, and you see there is no problem with that construction. But when we get a cement board from 9 till 12 millimeters, it didn't work anymore, and the construction became too wet. So that was no option for us. Yes, thermal lag. There's another principle we use, and the thermal lag means how quick does the warmth from outside get inside in hours. And I have a very nice picture here. Those two constructions are exactly the same, but not the insulation. The insulation is different. On the left side we have glass wool, on the right side we have cellulose. And you see the difference between the thermal lag. On the left side, it's 9.5 hours and 16 hours. So we are using these principles to make the step to low tech and to avoid using an air conditioning. Effusivity, well, we all know when we touch a concrete wall, it feels cold. When we touch a wall of wood, it feels warm. And this principle means that the indoor temperature can be much lower in wooden buildings. And this means that you can have an indoor temperature at 60 or 80 degrees. And it also is very comfortable. So we use these principles also. And every temperature you get lower in the indoor temperature, it saves 6 till 7% on costs of energy. And we use the principles of passive house, of course. I guess you know the principles, so I go a little bit faster now. This is a very interesting case I want to discuss with you. In this view, you can see that we used different kinds of principles to get a low-tech energy concept in the house. Of course, we used bio-based because of the thermal lag and because of the effusivity. But we also used the principle of the summer night ventilation, when you have all the doors and windows open and the wind blows through your house. And the wind blows through your house, but first the wind has been through the trees. And trees are cooling down also the temperature. So we are using nature also to get a comfortable indoor climate. And with this example, we actually had an energy concept of 8 kilowatt, but because we are using all those principles, we could lower it to 1.5 kilowatt. And because of that, you can also have a great advantage to the net congestion we have in the Netherlands. Well, our roadmap, a small heat pump, echt really slower, really smaller than we are used, no cooling, and balanced ventilation only in winter. And because we are bundling different principles and different characteristics, we can take the step to low-tech buildings. Thank you.
Thank you, Carla. You asked the question yourself, why are we still allowing these toxic materials, 128 million around us? Why are we?
I think there's one answer, to be honest. I think it is the lobbying from the very powerful industries. Mm-hmm. They don't want us to stop with it. You can also look at the discussion we had with glyphosate. It's the same discussion, I guess.
And if we get it, we go one level up. Why are we still allowing the industry and the lobby? Is it because the products are better? Is it because they deliver us comfort? Is it because it's cheaper? What would you say is the biggest problem?
The biggest problem is they want to keep selling their products. Okay. I guess that's the main reason. It's not healthier because I just told what's really more healthy for people. I had a slide of costs, but I didn't have time. It's not more expensive.
The question is almost too big because I'm asking you to explain what's at the core of a dysfunctional capitalist system, but which is interesting to discuss here. But let's come back to the question: why are we still allowing this in relation to the examples you guys are giving? So, any questions for now to Carla from the audience?
Yeah.
Hi. When did you find out these principles for yourself?
Now, I got in touch with my colleague who was also working at Aveco de Bondt, which I'm working now, and he studied building biology. His name was Max Draat. I guess most of people know him. He died, unfortunately, last year. So a little tribute to him also here. But he studied building biology in Germany, and he inspired me so much that I only could do one thing. I wanted to do that study too. And I learned all of what I told you in my presentation. I learned from him. I learned from the study, building biology, but I also learned a lot from Frank Schipper, which I told in the beginning of the presentation. He is building physicist, bouwfysicus, building physicist. Yes, he's building physicist, and I work with him a lot in all kind of projects. And I learned also from him a lot of these principles.
And about the Germans, are they ahead of us at the moment?
I'm not talking about football now.
No.
Well, I can't give you one answer. On the one hand, they are far ahead of us because building biology, it was already there in 1978. And but there's also a part of Germany which is really building a lot of buildings in concrete, and so it's two stories there.
Okay. Thanks, Carla Rongen. Rules and regulations with regard to climatization have become stricter and stricter in the last decades. But has it brought us better buildings, and could we do without? Next, he started at DGMR, worked at Arab, and is now a senior consultant at ABT. Please welcome Jacco Paauw.
Thank you. ABT-Lüning, I see. Well, it's ABT, but no problem. Is this working? Yeah. I am a building physicist by trade. I started way back. So a little bit about us. I started at the DGMR, just like Bas, for over 20 years. Then I joined Arab, and now I'm working for ABT for almost a year. This is what ABT looks like in the grand scheme of things. We are part of Oosterhof. Also part of Oosterhof are several other companies. Together we are providing multi-desk services to design sustainable buildings. But what's also in there is Quake. And Quake is an entity that is organized to promote innovations. So this study that I'm going to show you is a study done by Quake. And it is related to carbon, of course. And it starts with this big task that we all have, that is that we need to cut carbon. And the current track is already a big task, but it's not quick enough. We need to increase the speed. Otherwise, we run out of carbon budget at 2028. I think that's also what Willem showed. And that requires a big change. It's not just minimizing stuff and we need to do it differently. We need to reconsider. This is a not very scientifically underpinned graph. I made it myself, but the left part is true, and the right part is true, but the combination is a new one. But what you see happening is that we are at an extreme rate still consuming energy, and we are now at the stage that we need to cut down on carbon, and that is not just a change, that is a radical change. So we need to do something about this, and the first thing is to look back and say, how did we get here? This is the energy usage that we have, and I think it was your question, right? When did it all start? Well, you see here in the 50s, it exploded. This is not just about energy, it is also about material. When we look at our society, our cars are getting bigger and bigger. In the 70s, the biggest BMW weighed over 1,600 kilograms, but right now, the smaller model is already several hundred kilos more heavier. And it's not just the cars. It's us also. This also has a relation with your ill disease stuff. We developed obese. For the first time in 10,000 years, our life expectancy is reduced. Two main causes: stress and obese. Also, our buildings became heavier. 100 years ago, we built floors from timber. They stored carbon. Right now, we are designing concrete floors, 10 times heavier, emitting carbon. But they do insulate sound. Pretty good, though. When we look at the facade, it's not that much heavier, the facade, but it grew bigger. 200 millimeters width to 400 right now, and an improved insulation. So we are very well capable of keeping outside, really outside, isolate ourselves. And then the indoor climate. We did improve on the insulation part. In 1965, we did heat our houses with this gas heater to the left. And then we had central heating, way more efficient. Heat pumps. The glazing. We had single pane glazing in the 60s. Right now it's triple, quadruple. Vacuum glazing. So we improved the performance, the thermal performance, also 10 times. So you would think we would reduce our energy consumption for heating our homes. 75% increase per person for heating our homes. So what are we doing wrong? Well, we do have an increased efficiency by the building skin, the installations, so it's 9 times more efficient. But at the same time, we are heating our complete homes for 24 hours a day at a higher comfort level. Instead of, to the left, just a wood burner for 2-3 hours a day at 90 degrees. So that is the difference, 65% plus in energy. So what happened is that we grew bigger. We were heating our complete houses, buildings, distance from nature. We didn't want to experience anything from outside or from our neighbors. We increased our own isolation, our own bubble. So that's where we need to rethink. If we're designing buildings, if we're designing climate, if we're designing installations, and we look at carbon, then the biggest impact in reducing carbon starts right at the top here. That's your program of requirement. At what level do you want your comfort to be in this building? Biggest impact. And I think it would be way better if we could have a bit more nature in our buildings, a bit more outside on the inside of our buildings. There are several projects, famous projects, that already did do this in the past. One of them is Openluchtschool from Duiker. They designed this building in the 1930s. And they designed it for children with diseases like asthma, because it was a healthier building, a healthier school. If it's healthier for sick children, it's probably also healthier for us. And how do you design this indoor-outdoor climate in your home? Because there is a big scale on different climates that you can design in your building. The most extreme is outdoor to the left. The other extreme is hyper-controlled bubbles to the right. But there is a tremendous bandwidth that you can play with. We as human beings can adapt. Here in the middle, the comfort zone. we are designing buildings with a very small comfort zone. And that means that our body is not used to adjust. We don't need to. We are in perfect condition. That's why we grow bigger. Do you know that the energy that we use in our body to live and to move and to just for breathing and living, it's 60 to 70% of the energy consumption that we need to keep your core temperature stable. Well, what happens if you're always in the middle of your comfort zone? You don't need the energy. You grow bigger. But you can train that. You know? Sporters, athletes, they know how to train and they know how to adjust. So you can actively train your body to cope with cold, or extreme cold or extreme heat. It has a big impact on your health. Your lower heart rate, lower blood pressure, and your comfort zone increases. You know, it gets bigger. It's not just for athletes. You can also train yourself, your body, passively. Just adjust yourself, put yourself in a slightly warmer or slightly colder condition. Your body will adjust, your metabolic rate will rise with health benefits. So we know that it is not a very big problem to be sometimes a little bit uncomfortable. On the contrary, it has health benefits. So why don't we design a bit less controlled environments, a bit more outdoor in our buildings? If we're doing that, we can do that with zoning in buildings, because you're doing all kinds of different stuff in buildings, and not every place has to be fully controlled. Some places can be less controlled or even no control, no regulated climate. And that's exactly what we did for this project, Paleis van Justitie in The Hague. That's a courthouse, an existing courthouse, existing building. What we did there is we designed a bit more outdoor climate in the current courthouse. So we did create and design some climate zones in this courthouse. To the left, it's outdoor climate, and the deeper you go into the building, on the right-hand side, it's the courtroom. The courtroom needs to be controlled. So to the right-hand side is fully controlled. To the left-hand side is almost outdoor, and in between, lots of space for passive climatization. This is a section. What you see here is that traditionally, the green line, traditionally you would fully climatize this building. But now we are only climatizing the reception intensively, and the offices and the courtroom, and all the volume in between gets a passive climate, and it mimics a bit more outdoors. It's much more dynamic. And this enables us to reduce the installation rate. I did hear this question about, I think we can reduce the installation rate in this building with 30 to 40% because of this approach. But we're also using a different form of climatizing, not through set points, but with bandwidth. So we are allowing the temperature to be between 20 and 24 degrees Celsius, or 19 and 25, depending on which zone you're in. Not just between those hard lines, but also depending on what season are we in. So it might be a bit cooler in winter, and in summertime we allow it to increase, as you see on the right-hand side. That has a real, also energetic benefit. If we're introduce the zoning that I showed you, we are able to reduce the energy consumption with 30% for heating, lighting, ventilation. And if we are using this bandwidth control and the circadian arrangement, another 25% can we cut off from the energy consumption. So big gains. I think this is about the last slide. I got 2 more slides, but those are a bit engineering slides, so not very sexy. a quick lantern. So this is an office room that we modeled, simulated. To the left-hand side, the office room with a set point control, and to the right-hand side with a bandwidth control. And what you see happening, this is in a winter's day, is that the energy consumption for heating is reduced with 70%. So remaining 30%. In winter, 75%. So this is an extreme. This is winter, summertime. So in spring and in autumn, it will be less, but still valid. So to sum it up, I think this is the old one, right? The old presentation. Yeah. To sum it up, I would really like that this presentation is food for thought to reconsider this program of requirement, this first step, because if we allow ourselves to integrate a bit more outside, inside, then there is a lot to be gained. Thank you.
Thanks, Jacco. What did we you actually send us a new presentation this afternoon? Maybe something went wrong, excuse for that.
No problem.
What did we miss?
No, not much. I did
some
I
visuals.
just put some, I don't remember. That's why I needed the graph.
Thanks for your presentation. Thanks for, at the same time, solving obesity by a very simple adagium, just get out of your comfort zone, right? I sort of, during your presentations, I get the feeling that it's not that difficult, yet I start to get more pessimistic by the minute. How optimistic are you that we as a society can fix this, can make this U-turn?
I think it's a very difficult task, you know. But I think one of the main difficult things is to convince your clients that you need to change the program of requirement. For apartments, we have embedded this system in the bang, in the NTA 8800, that we need to comply with this, what is it called, Theo. So there's this thermal comfort index that you need to meet. Forget it. Yeah? But these private clients, they also have this program of requirement. If you're designing a building for a government, then the RVB has their standard program of requirement, and they tell you what your indoor climate needs to meet. And it's very difficult to have that change, that approach. So I'm very happy that we managed to do just that for Paleis Justitie. Mm-hmm. So that gives me hope.
What did it require for your clients? Why did they do it?
I think they were also driven by the sustainability that is needed, the cutting of carbon, but also the healthier environment it will gain. So, and what does happen is that the most important rooms in this courthouse, the courtrooms themselves and the offices, they are climatized. So it is, I think, the best of both worlds, and we were able to convince them. Yeah.
Any more questions to Jacco?
Yeah. Also earlier, I think we were taking more installations, but also we have 2 Paris-proof targets, I guess. The first one is already working on for 10 years, the energy reduction. Also the energy reduction of new buildings. We have to go to net zero in 2030, we assume. How does that match then? Do we have to skip that target, or do we have to switch that in another way? How do, yeah.
Well, I think the target for energy zero is fine, you know. We should move it a bit forward. But at the same rate, I think the focus nowadays is on cutting carbon in materials, because they expect that the new energy mix will be more sustainable by the year. In the Netherlands, we are doing quite well with wind and sun energy. So if we keep doing that, then the main target and the main challenge will be cutting carbon in the materials.
Is it an answer to your question, or not really, right?
Mm-hmm.
Yeah, the discussion also is, I guess, we have to the target of reducing our energy in buildings is like the red flag, and we want to focus on that. Now we have to. You have another
additional target.
Yeah, embodied. how do the installations, I guess, have to combine these? There are the
You need to combine it,
solution for the energy reduction targets, but how would
yeah,
so
well, I think what you're, I think it is, it can be combined. You know, I think that if we need to cut carbon in materials, we need to build more lightweight buildings. We need to use wood, timber for buildings. I think we can do that very well, and I think we need the bio-based materials, because building with other materials doesn't give us the advantage of storing carbon on the short term, and we need a short-term solution. We can take into account that in 75 years we are able to reuse some steel beams. That's too late. We need to cut carbon right now. So that's why I think that we need to build with timber and build with hempcrete and the bio-based materials that store carbon. And at the same time, if we are cutting on installations and we are reducing our comfort level, which has health benefits, then this is a double-edged sword, because we will also save energy at the same time.
All right. See you back in 15 minutes on stage after our last speaker, but give him a big hand. Jacco Paauw. Our last speaker will not talk about a passive house, which we have heard on, but about an active house, and he will discuss how to get the right balance between comfort, energy, and environment. He's the chairman of the Dutch affiliation of the International Active House Alliance, Active House NL, and an advisor sustainability and health at DGMR. So a former colleague of Jacco, right?
Yes, shortly.
Bas Hasselaar, please welcome to the stage.
Always kind of difficult to see yourself such larger than life on stage. I'm talking about integral design with Active House. It is sort of a prolongation of many of the things that all the speakers have talked about here earlier, but it will all make sense and it will come together with the end result. Yes, I work at DGMR. We are an engineering firm, one of the larger ones in the Netherlands. We pride ourselves on our quality and creativity, and we are working towards a more sustainable and safe and healthy work and living environment. This is just some of the things we do. We put our money where our mouth is. We have our own agenda and try and reduce our own carbon footprint. We have 3 offices, and you can see that we are steadily going towards, well, zero is maybe a stretch, but we are certainly reducing. And we're working, and I myself work at a lot of tender projects where we have quite ambitious goals. For example, here, Koffiefabriek in Amsterdam, with, I don't know how familiar you are with the Bing scores, but these are all energy neutral. Same with the MPG, so it's the environmental performance of a couple of tenders, where we achieve without the foundation, but we have an MPG score of 0.32 here, and they're 0.4, which is the current guidelines for construction in dwellings is 0.8. So this is quite low scores. And who am I? What keeps me occupied? I also like to put my money where my mouth is. I designed my own house. I built my own house. This is an active house. It's here at the bottom. I like simple and elegant solutions rather than the complex, very technical ones. And sustainability in the broadest sense of the word is the common thread throughout my life, both professionally and privately. I recently announced, so to speak, at my company that I will not work on projects anymore that have no ambition with regards to sustainability. And I built my own house, which apparently was a thing. So, you know, it says building physics designs his own house based on indoor climate. Why? Health is a healthy indoor climate leads to better performance. It's already mentioned here a couple of times. Healing environments for hospitals, people that lie in bed in a hospital near the window and have a view toward the outside, and it should not be a brick wall or a parking lot, but if they have view on a park, for example, they will significantly reduce their time in bed. There were studies where people had, I don't know, some appendicitis removed, for example, and if they had an indoor room without a window, they were in hospital for about four nights. And if they had a view towards the outside with a view on trees, they were 2.5 days in the hospital. You can imagine if you work in an environment like this and you have bad lighting, that you will make much more mistakes when rather in an environment with daylights and high quality. This is something that I stole from a different presentation in Denmark. This is, yeah, sorry about the quality, it's my phone. But this was an example of an institution where people with mental problems were institutionalized, and they were in an old building which was, you know, very sort of the old, maybe you've seen One Flew Over the Cuckoo's Nest, you know, these asylums, basically concrete cells, very not very comfortable. And people were having lots of problems. People were restrained. They were given sedation to be able to be managed better. And then they moved to a different location. They had a new building, only one floor, lots of greens. They had gardens and everything. And the forced fixation was reduced by 69%. And the 61% reduction in use of tranquilizers. That is only the quality of the building that does that, which is tremendous. I mean, this is criminal if you don't offer this to people. Anyway, around 1870, we were used to having an indoor temperature of 13 to 15 degrees. That was considered comfortable. And since then, we have increased our knowledge of building, our technological solutions, and right now, we have an indoor environment which is comfortable between 20 and 24 degrees, which is, of course, a tremendous waste of energy if you consider that 13 to 15 can also be considered comfortable. This is something that I borrowed from Wouter van Marken Lichtenbelt. I saw Jacco also using some of his slides. That the thermal environment has benefits. If you have a larger changes in the indoor environment, you have health benefits. You can get yourself used to lower temperatures. There was a study where people were obese, they had diabetes, and they were put in a controlled chamber. I think it was 15 degrees, but they only wore shorts and a t-shirt for 2 weeks. And for the first week, of course, they were complaining. They were very cold. They were shivering. But after about 10 days, they sort of got used to the temperature. And after 2 weeks, they were fine with being in 15 degrees. And even worse, or even better, they could reduce their medicine intake for their diabetes by 50%, purely by thermal training, basically. You can increase your comfort and resilience to cold, and it has a positive influence on, well, you've read it. So if you have an indoor environment which does not have very strict temperature levels, but you allow for more cooler temperatures in day or season, and higher temperatures in summer, for example, your body will appreciate it. You will get a higher metabolism. Your cardiovascular system is more challenged. And a temperature ramp of 17 to 25 degrees is comfortable, rather than 20 to 22. And of course, this tremendously reduces your dependence on climate installations. So if you allow this in your building design, you allow your indoor temperatures to drift that may be healthy. And it seems realistic to create it because this is from a university and a professor, so it's all it may be healthy, it seems realistic, but you get the drift. It will contribute to a sustainable built environment because we need less energy consumption for climate installations. Of course, this is not just the temperature. You need a good balance, diet. You need physical activity. All that stuff. But we can use this information, we can use this knowledge to create better buildings. Carla also showed this graph. I will explain it. The typical building business operating cost is 90% of the expenditures of a company goes towards staff and the salaries. Then you have about 9% of the cost that goes into the rent of a building, and about 1% is the energy consumption. What then if we apply a 10% variation? So we spend 10% more on a good quality indoor environment, so on the building installations. If that would increase our rental costs, and maybe with 1%. But if the staff cost and the salaries, if the efficiency and the performance of your employees improves only by 1%, you have already gained back your costs. And if you, as we could see in the presentation of Jacco and also of Carla, the indoor environment can have a tremendous effect on the performance of people. We can improve performance by 10-15%. So looking towards a comfortable indoor environment, and this is also why so many companies spend so much money on climate insulation. It's now 30, even 40% of a building, maybe on the premise of having everything very narrow climate zones, which may need to change. But this is why the indoor environment has an enormous benefit and effect on your staff. So then, Active House. As Geert introduced myself, I am the chairman of the Dutch Alliance of Active House. I've been a board member of International for about 5 years, and I have written actually these Active House guidelines, and I was the chief editor of the 3rd edition of the Active House specifications. And but what is Active House? Active House is a vision on how to build. It integrates comfort, energy, and environment. And it does this with 9 themes. This is an Active House radar diagram which you can use to convey the performance of a building towards even non-building professionals. Because the larger the surface area is, the better your building. And you can see here, this is an example of a calculation of a building with, I think this is, it doesn't work. Anyway, the light green stuff, that is the building before the renovation, and then after renovation, it was the dark green spot. So bigger is better. You can see that the building has a much better freshwater consumption. It has a much better energy performance, and the acoustic performance has improved tremendously. Active House works with both qualitative and quantitative measures. Some of these things, for example, the view outside of a window, you can't really put a number on that. You either have it or you don't. So it's a yes, no. It's not like 5 or something. So there are a number of aspects that are mostly design related that you can describe and explain, but other aspects such as how much daylight would you get inside your space, you can actually put a quantitative number on it. And this is one of the few, or maybe the only, label that I know of that has it has a weighted score. So rooms that are used more intensively by more people are weighed heavier than the rooms that are your spare bedroom, for example, that you use 3 days in a year. Good performance of that room is not as important as it is the main living room where you live most of your day or most of your life. So it works with daylight. I will skip through this a little bit quicker. If you're really interested, I will give you more information afterward. Thermal environment, air quality, acoustics. This is new since the 3rd edition. The energy demand of a building, energy supply, of course, and the primary energy performance, which are these three are very similar to the Bang scores, Bang 1, 2, and 3. Of course, the environmental performance, so the materials, and fresh water consumption. These are some examples. Top left is my own house, right after it was finished. It's much greener now because my garden has really sprung to life. This is the 5.4 dwelling, also received an Active House Award. I will dive into this a little bit more. This is very recently, just last month. This is a renovation of an old army barracks office in the center of the Netherlands. It's being retrofitted into a hotel, conference room, restaurant thingy. Also achieved an award. I was involved with that, and this is the International School in Copenhagen. Large building with BIPV on everything. Also one of the most inspiring active house buildings. So this, Bouwnovum 5.4, this is a company I've been involved with a couple of years back when I was in the process of designing my own house. We came up with a sort of a couple of guidelines on how to create the optimal building, the optimal house. And I've taken those things and designed my own house. They took the same input and created this. These are, well, terraced houses. You can make them 2 layers or put a third one on top. You can demount them. They're demountable, everything. But the interesting thing is that this is designed also from a building physical standpoint. So the inside, it's basically designed from the inside out. We work from indoor climate, and this is why all these houses have a solar chimney, which allows for 2 things. One, you can have summer night ventilation by opening the roof windows, and you allow daylight to penetrate right into the core of the building, even on the ground floor. It's, well, as you can see, made of wood. So as Jacco explained, we have lots of carbon storage in here. It has a negative carbon footprint. As you see here, it is frameless because the walls are made of CLT. So you don't need window frames, which is much easier and simpler from a material perspective and construction point of view. But still, you want to open your windows. So they have these spuiluiken, purge windows, thank you, purge grills. So you can open these in the middle and still purge your house and have ventilation free from burglary. I mean, people can't. You have it also on the ground floor, on the I think next to the kitchen. You can, next to your front door, you can open sort of a grill like that and have proper ventilation through the solar chimney and summer night cool your heat and everything. It's a very nice example of properly integrated design of a dwelling that is demountable, deconstruction, carbon-based, bio-based, and with a negative carbon footprint. I may have taken a little less time than I was allotted, but thank you.
Thanks, Bas. I'm giving you the first chair and take a seat. And
thank you.
Take the time. You've shown your own house twice, if I counted correctly. I guess it's awesome to live there. When did you start? When did you move?
I moved just under 7 years ago.
Okay, so you've been living there for 7 years.
Yes.
Share with us, honestly, the downside of living there. What does it take in terms of sacrifice in relation to comfort, living in an active house?
Honestly, it's mostly when I visit other people.
Because you're too overdressed, or?
No, I can't live. I can't imagine living myself in a regular house anymore, because the house that I designed is based on the cost of the house is similar to a regular traditional construction. but the performance is it's non. You can't really compare it. During the construction, for example, maybe I should have put a picture in there. My kitchen, my living kitchen, has doesn't have a floor above it. It's straight up 6 meters high. My sister-in-law, during construction, she came by, and of course she had heard about my plans, and she asked, "Why did you not put a floor in there? You know, your house could have been 30 square meters larger, and more is better." And so, well, it's not about the quantity of the square meter. I want the quality of the house. And when she came by, and she walked around my house and going like, "Oh yeah, now I see what you mean. Maybe you're right."
Yeah. But in all modesty, I asked you for the downside of living in your house.
Yes. The downside. I forgot to take acoustics into account, so my actually I changed my I originally I had a heat pump that used my internal exhaust air and regained the heat from it, and I was hung up on a wall, and I didn't have sufficient mass in that wall to accommodate the amount of vibration that the heat pump created.
Okay.
So I had whenever it
Your excuse for this minor detail.
Yes.
I'm asking this not to tease you. Also, that's always fun to do. But the reason is because that we are talking about that we have to make sacrifice in terms of comfort when
Yes.
when you strive to.
Oh, actually, I
Okay.
may have the original. When there was a calculation made for my house, and to determine how much, how many kilowatt hours of power I needed for creating hot water and heating. So the vermogen of my heat pump. Power, thank you. And it was calculated to be 6.9 kilowatt hours for my house, because it's a freestanding house.
Yeah.
And I decided against that and bought a heat pump that delivered only 2.5 kilowatt plus 1,500 electrical heating element in a boiler. So it's 4 kilowatt in total, or about 40% of what was originally calculated. And it worked. The only downside was
You can only shower for 20 seconds.
No, 20
Okay.
minutes.
Okay.
But my girlfriend likes to shower, and 20 minutes turned out to be not enough.
Okay. I'm going to ask the rest, Carla, Jacco, and Willem, to join us as well. I'll find you for questions, but first I have some questions for you, Willem. If I may start with you, take the last seat. You decided we had to have a night with the title, "We Need to Talk About Installations."
Yeah.
Have we talked about installations sufficiently tonight? Because we have been talking about installations, but we have also a lot of time not been talking about installations.
Yeah, so in that case, I think we made the point that we want to make.
Okay.
Because
Which
it's
is?
all about thinking, none of those things stand by themselves. It's not just about installations, it's not just about material. As I think was quite eloquently explained, there's a lot of benefits from looking at it from all different angles. Recall that we need to talk about installations, because maybe you know we need to talk about Kevin, the movie? Maybe not. Kevin is a very disturbed child. And what we noticed in the Carbon Lab, sorry, I'm looking into light, is that the installations are kind of, when you look at the embodied material or the embodied carbon question, it's a kind of a black box. No one really knows what's going on. That's why we wanted to research this into more depth. And I myself, I've learned again a lot tonight, so thanks for that.
And when we make the analogy with the movie, we need to talk about Kevin. Is it that the installations they are the symbol of our disturbed built environment, the brokenness of it, the addiction to a lot?
For me, they stand for somehow us not being able to ask the right question, or not providing the right answer to the question. So what we tried to do with the prototype, I'm not sure if I explained this correctly, we actually all worked on it, the design we showed before, to try to limit the installations and to learn from each other. How can we start from a different starting point? but I think I'm repeating myself now.
Yeah. Let's take a couple of minutes to sort of, I get the feeling, I'm not sure whether you share this with me, that it's quite clear where we should go. We know where we should go. On an optimistic note, we've totally screwed up, but we've started screwing up for 75 years ago. So we might be able to sort of get back or get to a place where we can do better. The only thing is that I think we're not really clear about how we should get there. So first question is, are you on the same page as, or on where we should go? And the second question is, how do we get there? Jacco, may I start with you?
What? Is this working?
I think so, yeah.
Yeah? Everybody hear me? I don't hear myself.
Let me check if the... Yeah, it's on.
It's on?
Yeah.
Okay. Yeah, now I can hear myself, yeah. I think we're on the same page. I think when I looked at the three presentations, and up front we were told, please, you may differ, we need a bit of a discussion, but I think that's going to be a problem, because I think in the end we're all looking the same way. I think that I'm pretty pessimistic, to be honest, because when I look at what we need to be doing to reduce carbon, and what we need to be doing with installation and climate change, and I'm pretty pessimistic, because the whole world revolves around energy, around business models. Just to put it into a bit of perspective, how weird is it that our economy needs to grow every year to maintain our prosperity? That is I think the essence of the problem that we have. So how do you convince that we need to change, and that we need to suffer a bit, because people are not prepared to suffer, and I don't think that that we need to suffer that much. But everybody wants to have it better next year. Yeah. And
let's use the analogy of an addiction. We're addicted to comfort. We're addicted to cheap products. We're addicted to fossil fuels.
When you look at the graph, up until now, everything is getting bigger, is growing. This is the supersized society.
Yeah. What if we stay with this analogy of an addiction? What does rehab look like? We know where we want to go. You've shown us tonight.
Yeah.
What does the process of?
I think to realize, for everybody to realize that we need to do it differently, and that that will require a change in approach. And that it is not that hard to just live with a little bit less comfort, because your body can adjust. So but people need to realize, and I think that's a big task.
Carla?
Well, to be honest, I'm very optimistic. I'm sorry. Well, when you look at the world about 30 years ago, I guess, when I see what kind of development we have made, I agree with your with your vision. I see that also, but what I also see is a development on PV panels. People want to do some sustainable things, and the windmills, and there is consciousness, and
there's also a lot of microplastics, PFAS, and vlamvertragers in our rivers, right? So we're not everything's going the right direction.
No, of course. But what I mean to say is there is consciousness about it right now, and we didn't have that about 10, 20, 30 years ago. And that keeps me optimistic.
Okay,
and
so
I
from
think
this,
it's necessary to keep optimistic.
It's absolutely necessary, and thank you for outing it here. But if we take this minor dose of optimism, And go back to the question I just asked, how do we get where we want to go? What are the biggest obstacles and how do we overcome them?
I think there have been done some great things in the EU with the Green Deal, and that will help us a lot. Also, the CSRD is coming to our companies and to our countries, and it's
The
going to
CSRD,
happen.
for people who don't know,
it's
and
an
for
obligation.
me, I don't know what the CSRD is, so.
Okay, it's an obligation for every company to have rapporteren. Hoe noem je dat?
To report on.
To report, yes, to report on sustainability, and that will be a big drive, I guess, for more sustainability in our countries. Besides that, I guess it's necessary to tell the story. So what we are doing here, and there's an exhibition right here in the Keilepand. That's very important.
Yeah. Bas, how is it with your optimism, and how do you see us getting from where we are now to the sort of the utopian future that has been sketched tonight?
Let me think about this. It very much depends from day to day. Sometimes I'm very doom-oriented, and I think we're all going to hell.
Yeah.
I mean, with everything going up in flames, and I will look around and watch the news. But on the other hand, I can be optimistic when I see that sustainability has become originally from something that we in Holland call the geitenwolle sokken, the goat wool socks.
I'm not sure whether it's a thing in English or in other countries.
Anyway, it was
doesn't matter.
The flower power.
Yeah.
You know, and it has become something that on the Amsterdam Zuidas, the place where people with money in suits.
Yeah.
If you want to rent out your office, you will need to have a BREEAM outstanding or a well out. The platinum. You need to be sustainable, and you need to be able to show it to the world. Otherwise, you're old news. Sustainability has become a business model, and it will always trickle down. When the big corporations and the heavy lifters and the people with money, when they want to show off their sustainability. People will look up to them and say, well, if he's driving an electric car, I want an electric car. Maybe you should take a bicycle, but you get the idea. I mean, sustainability is as you said already, there's more, people know about it now and realize it now, and they can look around and they see the world goes to shits because we haven't paid enough attention towards sustainability. And they're waking up, and especially the younger generation. Yeah. Basically, my age and lower.
I'm actually quite surprised about the doses of enthusiasm and optimism here. Willem, how about you?
Yeah, I'm always optimistic.
Architect, right?
Yeah, that's the nature of being an architect.
Jacco, what is it about architects? They're always optimistic.
They are always walking in the sun, I think.
Okay.
With the sunshades on. And I like that. I really like to be around architects because of that.
Okay.
But however, I'm not so optimistic about this arranging itself in the way you have just explained. I don't think we're in a time frame where that is any longer valid. I think that if you're addicted, you need an intervention. And the intervention is regulation. Regulation and politics based on facts and on science, not on opinions, on feelings, and that's what we really need.
Yeah.
We need regulation that brings down toxicity, that brings down carbon, and it needs to be super strict.
Can you make this concrete? What does this regulation look like? Where should
there should be CO2
budgets? Let's say the new cabinet wants to start with this tomorrow. We might doubt this.
For example,
what should they have on the top of their list?
They should form policy based on scientific input, not on what they think the voter may want to hear. Scientific input is super clear. There's no discussion about it. If that's not concrete enough, France has a very strong regulation on embodied material carbon. They did not wait for the European Union to come to a compromise or to have climate tables as we do it in Holland, which also has its benefits, I'm aware of that. There's a carbon ceiling for construction per meter. It's for the whole country, it's for any sector, and it works.
Okay. Any questions from the audience?
Yes, I have a question on the angle which is being approached, because installations, there's a lot of talk about energy, and it's very interesting angle you brought about the well-being and the comfort, but I'm wondering if that's the right angle to really have a radical change, because especially in the current era where everybody is talking about decarbonizing energy with PV panels and wind energy, etc., so people get the impression, why should I reduce my demand of energy? I mean, it's coming for free. And that's the definition of for free, which is the wrong one. And this is where the embodied carbon and the material impact should be more driven to the table, because I doubt if the comfort level will become mainstream. It's going to be still the niche, like a bit with meat eating. You will always have the niche vegetarian, and unfortunately, and is it more the perspective of realizing the awareness that it's not for free? It has still a material cost. That's maybe another angle just to approach.
Who wants to answer?
You were talking to me, I guess. It was part of my story anyway, but I think that if we can reconsider the level of climatization in our buildings, we are able to reduce the amount of insulation in our buildings. I've seen some examples of dwellings, but we're also talking about big offices like Palazzo Justitie that we saw. If we are able to reduce 30 to 40% of the installations, that also reduces the carbon footprint in the material. So I think
the driver for reducing shouldn't it be the price of material, the carbon price of materials, and not because it's gonna be more comfortable inside the building, because energy prices will be free.
No, that's true, but I think it cuts both ways. If we are able to show them that you also will benefit with a better climate, it will be better for your health. We need all the arguments that we can have to change the approach. It not just, if it's sufficient to price carbon, then okay, I'm fine with it, you know. But right now, that's not the case. And we did convince at RVB to implement this philosophy in this building.
You want to react?
Yeah, I think maybe it's not only about a price, but what about the behavior of people? What about their mentality? How to approach life in a sense that is sensitive to energy consumption, yes or no? It's also a mindset. So if you're addicted and you have to change your mindset, so how are you going to do that? So how we are going to convince everybody to join in?
Willem, Bas, you wanted to?
Yeah, I think that's where the health argument actually does come in, because everyone understands health. So that I think is a very attractive argument to use to propagate different ways of construction, because it's literally what you do. You live in a building, you recreate in a building, you work in a building, and if that's not healthy, then people would like that to change. That's my assumption.
And very simple. I mean, if you can reduce your installations by 30 to 40%, that also means that your investment cost reduces by 30 to 40%. And you know, money is a powerful tool, especially for developers.
We have a question in the back here.
Thank you for the presentation, actually. When large-scale private players are coming and asking for a climate class A building, how would you convince them to go for something lower in order to show them the benefits of it? Because if a large-scale player, not to name any, like CBRE, JLL wants to build a big tower in Amsterdam, and they come with a program of requirements, I need an office building of climate class A, no compromise, and architects are going to fill the building with glass. How do we strike the right balance among all these people? Because the developer wants the project and the architects are not going to compromise on the glass percentage. Then how do we take it forward from here?
I think there's actually a large responsibility that lies on the shoulders of the consultants. We have to like very early on in the process, take the commissioner and explain them, and not in 10 minutes, but like proper explain with presentations, and repeat that with 2 or 3 times with the board of directors, all the way up to whoever is involved and the architects, that their design language with lots of glass facades have consequences. And that may not always be, like if you're going to design something like that, it will have impact on the health of people, on the energy consumption, on your investment budget, and maybe you will need to make different choices.
The reason behind this is, like, maybe it's easy to convince, let's say with doing some calculation and simulation, it's easy to convince the architect to go lower in the glass percentage. But I personally find it very hard to change the program of requirement from CBRE or JLL itself to edit the document, that one line from climate class A to, let's say, C, for example. That takes so much effort and energy in convincing them, and maybe the consultants on the other day, and as a business model, they don't want to lose such a big client as well. So where do we strike a good business case that benefits everyone?
I think this comes from several directions. The previously mentioned sustainable reporting, CBRE has to definitely, it's one of those parties that will have to do this pretty soon, or they already have to. So they can no longer have a program of demands on their portfolio that doesn't take this into account. So again, regulation. Another way of looking at it, again from regulation, we just handed in a tender for a project in Amsterdam, where the points to be gained were based on a low MPGA, on a GWPA score that was the lowest. So the city regulates whoever hands it in, whoever is the market party. If you don't deal with the embodied carbon question, and therefore we had to talk about installations in sketch design stage, then you just don't win the tender. So we have to regulate this, we have to incentivize it in such a way that those parties who don't want to simply have no choice anymore. It sounds very pressing and negative, but I think it's the only way to do it.
No, I can give an example of something that is very matching with what you just described. I'll keep this anonymously, but I was working for a major corporation in the Netherlands, very high, dependent on the public eye, so to speak, and they were building new headquarters in Amsterdam, and I was involved in the design of that as a consultant. And we had worked on this project for, let's say, a year and a half. We were ready with the design, we were asking for the permit, and then the board of directors said, hang on, what about Paris proof? Tell me we are Paris proof, because we're about to send out a notice towards the media that this our new company headquarters will be Paris proof. And we actually had to get them back, say you will not. I mean, Paris proof for new construction basically means that your carbon budget is 0, and this design that you have ratified, it is not. And that was, they were shocked. And had this question come earlier, like 2 years earlier, I'm pretty sure we would have had a different design.
Would they have asked 2 years earlier, or did the public opinion change in such a rapid pace that this was the moment they started to realize that this was an important thing to think about?
It was something they overlooked. I think Paris proof is becoming more. There's somebody probably who asked the board of directors, like, hang on, in a year from now we will have a new office building, or 2 years from now, and you can be sure that the media is going to ask, like, oh, you have this beautiful new building here in Amsterdam, and is it Paris proof? And then we're going to have to say no.
And which company was it?
I'm not going to say.
Oh, okay.
Hi, thank you very much for your presentation, very insightful. I have a question, however, I take it for granted that sustainability is comfortable and it is sexy, but we are very focused on the west of the world, and we're not really talking here in this platform about what is happening everywhere else in the world that is the most populated, the largest, the youngest, where, of course, and I refer to something that William has shown me a couple of days ago, sprawl is not a case, the skyscraper is not the case. What is the case is the block, which is probably also co-housing, maybe a good model to think about. So society needs to think about sharing spaces with other people. We don't like that, but we will be going that direction. What about the rest of the world, where maybe they do want to achieve that single house in the middle of nowhere, and they also deserve it since we have lived this privilege for a really long time. How do you answer that question?
When you finished your sentence, you looked at me, so yeah, I go first. But I think I'm interested in the other answers to your questions.
You brought up Paris, you know, you got knowledge abroad, right?
Yeah, but that's not the abroad that this question is about, I think. This question came up a few times before, also when we had the exchange with Baltimore. We know each other from exchanging information with Baltimore. We work in Holland. As an office, we only work in Holland, except Antwerp. We have influence here in what we do, and this may sound like semi-colonial, but I think it is within our power to do things here and show to other parts of the world what can be done. We can probably also learn from other parts of the world. I'm not saying that we have all the knowledge and others don't. And I think a lot of the solutions you saw today are probably common practice in large parts of the world, where here they are no longer common practice. So.
Yeah, I think we can learn from the Scandinavian countries, because they are used to work with timber. But at the same time, when you look at the Netherlands, and we were talking about installations today, you know, but I think we are one of the few countries that has a perfect soil for these hot and cold storage systems that really improve our energy performance. I think there are a lot of countries that are envious on us for that one.
I'm going to stop you for now because we're almost out of time. Is there, and there were a number of hands in the audience, is there anybody who has a question that absolutely must be asked en group? You're in doubt? Who yeah?
I actually wanted to respond to what you had to say, because I come from a different part of the world. So I'm familiar now with where we are now and the rest of the world, let's say. Well, not the rest of the world, a part of it. And also touching upon, I especially really like the social aspect of this whole topic. I think there's a huge amount of potential there. I think technical stuff, we always solve the technical part before the social part. So, you touched upon, I think, yeah, many of you touched upon like the temperature ranges of like 15 to 25 instead of the 20 to 23. But what about 25 to 40? Because I think we will be seeing more and more, let's say, longer periods of those temperatures also in countries like the Netherlands. And then for solutions to those temperatures, we will be looking at other parts of the world because they've already been doing that. And the sad thing is, like countries like, I mean, I come from India, let's say countries in South Asia, I can speak more for that part of the world. Sadly, we look at, instead of what was already being done where we are, we look to countries in Europe and countries in North America. So it's like this whole cycle that everybody's following, which is completely unnecessary. I keep hoping that some other countries skip the mistakes of some other countries and just say where they are, or yeah, I think you know what I mean. So actually the responsibility in countries here is way bigger than we think it is. So yeah, it's a very relevant event today.
Yeah, and I think it means design will become much more local again, because solutions that work here don't work in other places.
There was a question, but it was also just the perfect concluding remarks. Thank you for that. Thank you for being here with us. I would like to invite you to the bar, have a drink with us. We will be back on the 12th? Yeah, 12th of September. Week prior to that, on the 4th of September, there's a special IABR, IABR. It's a Carbon Stories sort of affiliation as well in the new institute. IABR opens next weekend, Nature of Hope, and the exhibition, which is on display until the 15th of December. Please check it out if you not already haven't. And thank you for now. Willem van Genugten, Jacco Paauw, Carla Rongen en Bas Hasselaar. Zal ik die aannemen van je? Dankjewel, Bas. Zullen we ruilen? Dankjewel.
Dankjewel, Jacco.